All right, so now we're looking at the quiz that we took on chapter 3. All right, so there's more than one version. So again, I'm going to go over version A. The questions are in the same order. The only thing that's mixed up are the choices. Okay? So question number 1 and number 2 are definitions. Question 1 and 2 are definitions. So, the two definitions are knowing the difference between scalar and vector quantities. Okay? So before we do anything else in this chapter or subsequent chapters, we need to know the difference between a scalar and a vector. So here's the key here. When we're reading questions, we need to look for keywords. So the difference is no direction is scalar and having direction is vector. That's it. Okay? So there really wasn't a reason. The only thing is maybe you didn't look at your notes to study for the test. Okay? But this was in your notes on the first page. Scalar and vector. Okay? Now, believe it or not, number 3 was the most missed multiple choice question. Okay? So number 3, now remember, when you read a question, we're going to go over step by step how we kind of dissect a question. Remember when we said we talked about FRQs, and I said how you chunk it? You write down one thing at a time, okay? You need to do the same thing with multiple choice. Don't read the whole thing because you might get confused. And then you need to think about important things. So it says, in the figure above, which diagram represents the vector addition of A plus B? So here's A and here's B, okay? So now it says the vector addition. So the vector addition is I want to find the sum. But when I add vectors, I don't add them algebraically. I add vectors vectorially, and there's one rule for adding vectors. Vectors are added head to tail. Head to tail. Oh, my blue marker doesn't work anymore. Okay, so head to tail is the one word. Now, head to tail doesn't mean the resultant. That means how do I add the vectors that I'm adding up? Okay, so here, let's start with vector A. So let's say I draw vector A first. And let me just draw it on a separate piece of paper. So let's say I start off with vector A like this. From the head of this vector, I do the tail of the other, so B goes down like this. Then from where I start to where I end up, I draw my line. Where I start is the tail of the resultant, and where I end up is the head of the resultant. Okay, and this is my resultant magnitude and direction. Now someone said, oh, but these are head to head. This is the resultant, and that's the vector I'm adding up. Okay, so when we say vectors are added head to tail, it's only the ones I'm adding up. Okay, these two added together head to tail are equivalent to this. Okay, now what if I said, you know what, let me do B first. And then from the head of that vector, I do the tail of the other. Here's A. From where I start to where I end up, here's my resultant. Did I look the same? Yes. So it doesn't matter if I do A plus B or B plus A, the magnitude and direction of the resultant are the same, right? Okay. All right, so that was number 3. All right, number 4. It says an object is displaced 12 meters to the right. Now remember, when you have a quiz like this, you can write whatever you want on the quiz. So what you should be doing is you should be drawing your work, doing your work on the quiz. Okay? So I'm going to show you over here big so you can see it. So this is number 4. So it says an object is displaced 12 meters to the right. So I'm just going to draw like this, 12, and that's going to represent 12 meters to the right. then 16 meters upward. So from the head of this vector, I'm going to do the tail of the other, and that's 16 up. So it says the magnitude of the resultant displacement is, so this is where I started, and it doesn't even ask you for the direction, because the word magnitude, see, whenever you see the word magnitude, magnitude in layman's terms means how much. And it's just going to be a number and a unit, and that means if it just says the magnitude, that means I don't care about the direction. Okay? So let's go back to the problem. This is where I started. This is where I end. So I'm going to draw a straight line. Where I start is the tail. Where I end up is the head. And this is where I put my arrow. Now, we don't even care about the direction. Now, if you notice, did you have to do work for this problem? Now, if you're taking the SAT or SAT, first of all, this is going to be on the math part of the ACT or SAT. Okay? This is a 3, 4, 5 triangle, isn't it? So this 12, 16, 20. And that's it. You didn't even have to use your calculator. And this is the type of thing that's on the SAT, because on the ACT, you have 60 minutes to do 60 math questions. So when they have something exactly like this, because honestly, this really isn't a physics question. Okay, this is math. This is a 3, 4, 5 right triangle. Okay? And you didn't even need your calculator. You should have recognized. This is exactly a question on the ACT, which you should be able to do in like less than a minute. Okay? Easily. Right? All right, so that's number 4. Number 5. It says, a girl attempts to swim directly across a stream 15 meters wide. Okay? I don't know what across is, it doesn't matter. So let's pretend. Now, what I want you to show you is when I do this, you see how I draw a picture? Do I do anything in my head? So I found it very interesting when I was grading the quizzes, a lot of you wrote nothing. I'm going to teach you an important skill in life. When you want to succeed, most of us are conceptual. The more you write down on paper, the less likely you are to make a mistake. This is not the type of thing you do in your head. I see people and they're going like this, pressing buttons on their calculator. Write it down. Remember, when we take our test tomorrow, you're going to have your test, you're going to have your FRQ paper, you're going to flip over the back of your FRQ paper, and you're going to put it right next to the multiple choice, and that's going to be your scrap. Okay? So, now I'm not going to try and do this in my head. I'm going to write it down to help me visualize, and that's how I'm going to get a good grade. So it says, a girl attempts to swim directly across a stream 15 meters wide. So I'm going to go like this, and I'm going to say that's across. I'm going to say 15. When she reaches the other side, she's 15 meters downstream. From the head of this vector, I'm going to do the tail of the other. And it says the magnitude of her displacement. So again, they don't want the direction. So this is where I start. This is where I end. I'm going to go like this. Now, is this a right triangle? Now, some of you did this over and over again, and I didn't even know what to think. All the problems that were a right triangle, and that was all we did in our homework, A and B. You guys said 15 plus 15 is 30. Is that how I find the hypotenuse of a right triangle? No, I have to use the Pythagorean theorem. So I'm not really sure. Maybe you guys were tired. So 15 squared plus 15 squared. Maybe you were tired when you did the quiz. I'm not really sure. But some of you missed every single one of these because instead of using the Pythagorean theorem, you just added the two sides of the right triangle. And honestly, that's not really physics, right? I mean, this is, again, could this be a possible ACT type question? Absolutely. Absolutely. All right, so let's go to number 6. So number 6 says, two vectors are at right angles to each other and have magnitudes of 6 and 8. They have 6 and 8. So the resultant would be, again, I didn't even bother drawing a picture for this, okay? Because if I have a vector that's 6, and then I have a vector that's 8, and they're at right angles to each other, again, what do we have here? A 3, 4, 5 triangle, so the answer would be 10. Whenever you take a standardized test, they have the most common mistake. 8 plus 6 is what? 14. Is that a choice? How many of you put that? A lot. Too many. No one should have put that. If these are perpendicular, you're going to use Pythagorean theorem. Do I even need to use the Pythagorean theorem? It's a 3, 4, 5 triangle. Okay? So I don't know who or what math teacher you had. If your math teacher didn't tell you about, teach you about triangles, you know, like 45, 45, 90, and 3, 4, 5 triangles, if you're taking the SAT or ACT this year, please study those, because that's on a lot of questions, okay? And it's going to save you time, even in this class on the multiple choice, to even put stuff in your calculator if you recognize it's a 3, 4, 5 triangle, right? All right, what number was that? That was number 6. Number 7. This is just like the one on the review sheet we did yesterday, and that means it's going to be just like one on your test tomorrow. So it says, if a woman runs 100 meters north, and someone said yesterday in this class, they said, hey, that was the same exact question on the quiz, right? No, on the review sheet. So here's 100, and again, this would be 100 meters north. And then from the head of this vector, I'll do the tail of the other. This is 70 meters south. This is where I started. This is where I end up. So there's my vector, which is 30 meters north. Now, a lot of you didn't do it that way. A lot of you just said, okay, I'm going 100 north, 70 south. You knew it was 30 north. A lot of you did that without drawing a picture. But you could do it using our physics method. You see that? And you're still going to get the same answer if you want to visualize it. All right. Number 8. It says identify the following quantities are scalar or vector. So this was in the definition, the first. So the speed of a snail. So remember we talked about speed and velocity. So speed is scalar and velocity is vector. So we knew this is scalar. Then it says the time. Well, time is scalar. Time doesn't have a direction. And someone said to me, but you always tell us you can't go backwards in time. So I said, yeah, that means time can't be negative. But time doesn't have a direction, so it's scalar. And then the free fall acceleration. Well, free fall acceleration is little g, right? And we always say little g always points in which direction? Down. So it definitely has a direction. So it's negative 9.8 meters per second squared. So that one has a direction. So that one is vector. So when you were doing the test, I'm not sure, like as you were reading each question, like what you were thinking, okay? But what I was showing you today, going over them, that is, at least for me, how I think and do each question. But you notice I write a lot of stuff down, okay? Because when you draw a picture and write it down, and that's how we're going to learn all year long, the more you write down on paper, the better it is to conceptualize, and the better you will understand it, okay? All right. And luckily yesterday we had a root word quiz, and that root word quiz, hopefully everyone got 100, and that's going to balance out if you didn't do as well as you wanted. All right, the FRQs on the back. I said one was going to be on practice A, and one was going to be on practice B, okay? So for practice A, it said doctor. Now the difference is, I think I just changed the numbers. So this is A, and then for quiz B, the numbers are just a little different, okay? So again, there's more than one version, so just the numbers are a little bit different, okay? All right, so we'll go over this one. So it says Dr. Ionetti walks 2.3 meters east. So what I did was I picked a starting point, and I drew she went 2.3 meters east, okay? Now you notice this is the work I drew for my quiz, so it's kind of messy, all right? Then it says, and then 7 meters north. So from the head of this vector, I did the tail of the other. What are the magnitude and direction? There's a typo there, grammar, of her displacement with respect to her rigid. So I even say here magnitude and direction. So first of all, some of you didn't do the direction. Does it clearly say there that you have to show the direction? And the direction is more than just northeast. Remember we calculated our arrows? Remember I drew that little picture like this with north, south, east, and west? And I said things like north of east, east of west, and stuff like that. So I didn't just do that for fun, in class. This wasn't just for fun. That's what you had to do in your answer. But that's what we did on the homework in practice A, right? It wasn't anything we didn't do in our homework. All right, so now here's my two vectors head to tail. This is where I start. This is where I end. Where I start, this is going to be the tail of the resultant. And where I end, this is going to be the head of the resultant. So now here's my resultant. Usually it's easy to measure the angle inside the triangle. So to find, this is a right triangle. Okay? If I have the two sides of a right triangle, should I be able to find the third side? Yes. So what do? I use Pythagorean theorem. So then I need to find the angle. So to use the angle, tangent is opposite over adjacent. Now, there were some of you who, when you show your work, you're going to get partial credit. So there were people who showed their work and maybe this was wrong or this was wrong. Then I only take off 1 point. But see, when you show all your work on FRQs, like here I didn't do it, but you should have written that like, let's say displacement is equal to, let's say like x squared plus y squared, whatever. And then you show the values you're putting in. You're going to get partial credit if you press the wrong button on the calculator. You're just losing 1 point for the answer. Okay? Then here, some of you messed up on the angle, but if you set it up like this and you just had the angle wrong, I only took off 1 point. If you got the direction wrong, I took off 1 point. Okay? So now, let's look at the calculator. So on the calculator, I would press 7 divided by 2.3. Wait, let me do that over. 7 divided by 2.3 equals. Okay? Now, if you look at the calculator behind the tan button, it says tan to the -1. So then I press second tan, and you see how it says 71.8 degrees? So I just put 72, because we're not worrying about significant figures. Okay? That's all we had to do for this question. All right, next one. I'm not really sure what happened here, because I had people that left both FRQs blank. I have a vector. You know, I did it on the computer. Maybe I didn't do it clearly. I said find the horizontal and vertical components of the vector, and then I was showing you that this angle here is 60 degrees. This was practice B. That's all we did in practice B. So this is my x component. From the head of that vector, I do the tail of the other. This is the y component. Okay? So, sine, cosine, or tangent. Well, if you're not sure, write it down. Sine of theta is opposite over hypotenuse. So if I look at my picture here, and let's say I want to find, so if I do sine of 60 is opposite. What's opposite that? Y over the hypotenuse, which is 25. So y is equal to 25 sine of 60. So now if I want to put it in my calculator, I press, watch this, if you're not sure how to do it in the calculator, I'm going to press 60 sine times 25 equals, and it says 21.65, so I wrote 21.7. Okay? Then maybe I need to write my definition down. Cosine of theta is adjacent over hypotenuse. So cosine of 60, now I'm going to look at my picture. Adjacent means next to, so it's x, over the hypotenuse, which is 25. So 25 cosine of 60 is equal to x. if you wrote all this down, but you pressed the wrong buttons on your calculator, you still got most of the credit for the problem. Okay? There were some of you who did that. So you did all this, but maybe you weren't sure how to press the button, so the final answer was wrong. So I maybe took off 1 point for each one. So you still got 8 out of 10. Okay? But when you just write an answer, you're not getting credit. Okay? You're not getting credit when you just write an answer. All right. So now let's do this one. So on my calculator, these are the buttons. First, I'm going to press 60 cosine times 25 equals 12.5. And that's it. Okay? So this is our quiz. I will upload this to Edline if you want, for you to look at, if you want to look at it, or for the people that are absent, because we have people absent today.